Hi, this is Hosapin Bharti and welcome to a brand new episode of State of Energy. We are here in Paris for LF Energy Summit and today we have with us Pierre Segonne, your tech lead at Electricity Maps. Pierre, it's great to have you on the show.
Thank you.
Before we get started, with the project, of course, we are going to talk about Carbon Data Specification Consortium. We covered that earlier on our show as well. So we'll talk about that project as well. But I want to start with Electricity Map. What are you folks do?
So Electricity Maps was founded with the intention of using data for climate action. And we specifically choose to use electricity data to compute carbon emissions worldwide related to electricity production and consumption. And the way we do this is that we have an open core where hundreds, if not thousands of contributors help us identify data sources for public data sources for electricity, build parsers for those, and then we're going to be able to ingest all of that data, harmonize it, process it, fill in any of the missing values, and provide that to any consumer in a standard and consistent way. And we provide that data through for means. So we have a completely free app which shows in real time the electricity mix for more than 180 zones across the world, as well as the associated carbon emissions. And we are also providing an API that people can integrate into their products to do smart charging, carbon accounting, or any other activity that requires carbon electricity data.
How you got associated with LF Energy?
We got approached by the second working group of the Carbon Data Specification because its aim is to create a standard data format for power systems operator to share data about electricity grids. And it's very much in line with what we do at Electricity Maps because in our everyday life, we have to deal with the complexity that lies in having to source data from more than 100 sources. So there was a good synergy for making our own job at Electricity Maps easier, and at the same time making it possible for people that don't have as much resources and the large base of contributors that are helping us with all of these data sources to access power system data in a consistent fashion.
When we look at power system or the whole ecosystem today, it is a bit different because of renewables, electric cars, solar roofs, batteries at home. Just like media consumption, we are not just consuming Netflix, we're also creating a lot of content, TikToks, Twitters or Instagram. We are putting a lot of data back on the internet. Same with the electricity, we are sending a lot of electrons back. So talk a bit about how this ecosystem has evolved and what does that mean for Electricity Maps?
Well, we can see that as more capacity is installed on the distribution side, so that means, as you said, solar rooftop, for example, or even renewable generation, but at a smaller scale, that is not directly connected to transmission lines, then that creates quite a lot of complexity for the grid. Because all of that new load needs to be managed at the distribution side, which has not necessarily been designed to deal with that complexity. And so it doesn't directly affect us today that much at Electricity Maps because we focus on the transmission system level. But it does create a risk for us in the future because if most of the generation in certain zones come from distributed sources and is not captured at the transmission level, we're not going to be able to report on that data and not going to be able to account for it. And we hope that through the work that we've been doing through the Linux Foundation Energy, for example, the reporting of data for these new types of generation might become more common and and more generalized.
And of course, if I'm not wrong, you folks do a lot of open source electricity maps. Is also available on GitHub. First of all, talk about why you folks decided to open source some of your code base.
So it started with the electricity map was founded in 2016 as a hobby project. And the founder, Olivier Corradi, could not build what he had in mind himself. And so he had this idea that by involving other people and giving them a good reason, some sort of feedback loop for getting involved in the project, he could actually reach a scale that would be completely unattainable on his own. And so he thought that by open sourcing the core of electricity maps, which is the sourcing of the data, and by open sourcing the visual aspect of it, so the map, then people could go on the project, see that they can add a country that is not being shown yet, find the data source, build a parser, and then automatically this country will start appearing on the map, giving them that reward and in the end a good reason for contributing. So that's the whole idea behind it.
How widely used is this project across the globe?
We have, so in total, more than 1,000 people have contributed, which makes it the largest and most popular climate change open source repository on GitHub. On a daily basis, we are looking at between 30 to 100,000 unique active users. And they're spread across the world, with the largest proportion being in Europe. But we also see significant numbers in the US, Oceania, and Asia.
When we look at climate change, it's very complicated, very complex. It's also nowadays becoming a politically loaded problem. Some folks will dismiss it as coronavirus. Hey, it's not real. But let's stay realistic. Can you talk about what role do you see open source and organizations like Left Energy play in helping organizations who do want to tackle with this problem?
A big problem with climate change is responsibility and fairness. And so I personally see open source as a way to address these problems, where people come on an equal basis to try to contribute as much as they can to mitigate this sort of problem. And so I think it makes it easier for these projects to resonate in places that lack the means or that are impacted more severely by, for example, climate change than others to accept them as serious propositions.
Now let's scale back and talk about Carbon Data Specification Consortium. Talk a bit about how much progress is being done on that working group. Where are we now?
Yeah, so the whole specification work started last year. And the work was divided into 3 different work streams. The first one was to define specification for how to represent any given electricity grid with the same taxonomy and the same sort of abstraction. The second work stream was dedicated to agreeing on what data types should be included for describing any of these grid entities. And so we've built, and together with all the members of the working group, which includes power data aggregators such as us, but also Watt Time or Watt Carbon or Singularity, together with large corporate buyers of electricity, such as Google, Microsoft, Apple, Meta, and utilities or electricity providers or these sort of companies. So together with those, we have agreed on these first 2 specifications as the basis for future work. And now we're in the third work stream. We have started this, where the intention is to create a real API that is live and public, that can demonstrate how this specification can be implemented in practice. And we have released the first version of this API and are gathering feedback around this, its usability, and so on, to then take it on the next step, which will be to start advocating for its implementation with power system operators.
Can you also talk about the business value or not commercial but economic value of project like that? Because sometimes a lot of projects are more about just how good you are playing with the, hey, we are already eco-friendly company, but I want to talk about the actual, when you look at companies like Meta, Google, Microsoft, Apple, it should also align with their business goals as well. Hey, by using this, we're actually cutting down a lot of expenses as well. So can you talk about the impact on economy through these projects?
I think that the business impact that this kind of project can have is on the longer term as some sort of hedging against future regulations that will, I hope, force some companies to disclose carbon data, carbon emissions, carbon footprint. And so in regard to that, they need to have the tools ready for when these regulations might appear, so that they can comply without having to invest a lot of money then to comply for it.
If you just look at the projects, we talk about where the project is, we talk about the origin of the project, but let's talk about what this project has achieved so far. Can you talk about some of the output, rewards of this work that you are doing with this working group?
One of the most rewarding interactions we've had was after we've introduced that API demonstrator to the people at NCOE, which is the organization that oversees all TSOs in Europe and shares openly their data for them. And they were first, they agreed that the way we've designed the specification makes sense. And they also saw quite a lot of value into doing this specification work now, as some regulations are coming up. So the Article 20A of the Renewable Energy Directive in Europe, and something similar in the US. I forgot the exact name. But yeah, regulations are coming up which will be forcing these power systems operators to disclose the carbon intensity of the electricity on their grid. And they realize that if we don't have a common way of reporting this data, it's going to be hard to adopt a common way for computing carbon emissions related to that. So it was very encouraging to see that they were interested in joining in and trying to help us share this as API demonstrator and create momentum for later usage with carbon data.
If you just look at this working group, can you talk about what are some of the bigger challenges that are there for you folks? Is it about outreach to actually convince companies to leverage this data, or you feel that no, the challenges are more on technical side?
There are challenges on both sides. Technically, it is quite complex to find the right level of traction, the right type definitions for application on electricity grids worldwide, which might work in very different fashions. But I think that we can overcome these with enough time and input from the different actors within the different electricity systems. Where it gets a bit more complicated is to convince the different power system operators, that it would be beneficial not only for them, but also to the general public to adopt this standardization and to make it easier for people to consume the data they spend so much effort opening up publicly.
Yeah, thank you so much for taking time out today and not only talk about electricity map, the Carbon Data Specification Consortium, but also the wider problem related to climate change. Thanks for sharing those insights, and I would love to chat with you again. Thank you.
My pleasure. See you again.